Welcome to solverfy.
This is the answer to Chapter 16, problem number 37 from the Smith Organic Chemistry textbook. And this problem asks us to draw the structure of each compound. So we're given four names and asked to draw the structures that correspond to those names. So for A, we have 3Z13-pentadiene in the S-trans conformation. And so we're going to want these double bonds on either side of the sigma bond, which is what S-trans means. And so it's 1,3-pentadiene. So 5-carbon chain, double bonds at carbons 1 and 3. 3 is a Z double bond, and this molecule is in the S-trans conformation. And so taken all together, that is going to look like this. So there's our S-trans conformation. There's the Z configuration of our double bond, and that's a 5-carbon chain. And so there is the answer to A. So then for B, we have 2E4Z, 1-bromo, 3-methyl, 2,4-hexadiene. So hexadiene, our longest chain is going to be a 6-carbon chain. We have a bromine substituted on carbon 1, double bonds at carbons 2 and 4. 2 is in the E conformation, 4 is in the Z conformation. And then we have a methyl substituent at carbon 3. Okay, and so we can start with the bromine since it's 1-bromo. So let's do that. So there's carbon 1, carbon 2. So we have an E-configured double bond here. So that is going to look like this. So our chain needs to continue that way, but we also have a methyl group at carbon 3. So let's draw that. So there's our 3-methyl. And then 4Z. So to make it Z, it's going to have to look like that. Okay, and so there we go. That is the answer to B. Okay, so then for C, 2E, 4E, 6E, 2,4-octatriene. Okay, and so this is just 2,4,6-octatriene with all the double bonds in the E configuration. So that's pretty straightforward. 4, 5, 6, 7, 8. So 2, 4, 6. All of these are E configured, and that's all that C is. Okay. So then D is 2E, 4E, 3-methyl, 2,4-hexadiene in the S-cis conformation. Okay, so we have a diene again at carbons 2 and 4. They need to be in the S-cis conformation, and this is the longest chain is going to be a 6-carbon chain since it's a hexadiene. And so I'm going to draw this like this. So 1, 2, 3, 4, 5, 6. S-cis is going to mean that our two double bonds are on the same side of the sigma bond there. So like that. And then a methyl group at carbon 3. Okay. And so there we go. That's all that there is to that molecule. Yeah, and so this is a pretty straightforward problem. We do just need to remember how to go from structural features in the name of a compound, how to actually draw them, and remember what S-cis and S-trans mean, and just apply that to these four names that were given here. And that's the answer to Chapter 16, problem number 37.